All right, you little mathematicians, let's find the area of some regular polygons. First things first, we need to know what the heck a regular polygon is. So here's the definition. A regular polygon is a polygon that has all equal sides and equal angles. So can you think of a four-sided figure, a quadrilateral, that is a regular polygon where all equal sides and all equal angles? You are correct. It is the beloved square. And if we were thinking about triangles, what would be a regular polygon that's a triangle, all equal sides and equal angles? Correct again, an equilateral triangle, which we could represent with these clever little hash marks. So now trying to find the area of some other regular polygons that have more sides than shapes we've dealt with so far this year. So let's try to find the area of the regular hexagon, illustrated here, if every side has a length of 10 and a line segment GH has a length of 7. Now notice about line segment GH, it goes from the midpoint, the middle of this line segment, it goes from here, G, to the center of the whole shape. And it has a length of 7. Try to think for a moment, how could we try to find the area of this whole thing? I'm going to give you a clue. We're not using any knowledge that we don't already have, that we haven't already learned this year when we were learning triangles and quadrilaterals and other shapes. That is correct. We are going to divide our shape up into several triangles. You can see here's a triangle, here's a triangle. We took our hexagon and we cut it into 6 triangles. Now a hexagon has 6 sides, and when we cut it up, we have 6 triangles. Now look at this triangle here. We know the base is 10. It tells us here every side has a length of 10. And we know the height of our triangle is 7, right? It tells us right there. So how are we going to solve for this? Well, we know a few things. We know that the area of a triangle equals 1/2 base times height. Or you could, of course, write that the area is base times height divided by 2. So I will choose for our purposes now to use this equation. So we know our area is going to equal, our base is 10, our height is 7 divided by 2. 10 times 7 is 70. 70 divided by 2 is 35. And so I'm running out of space, but our area equals 35. So the area of one triangle is 35. But like I was saying earlier, there are 6 triangles. 1, 2, 3, 4, 5, 6. So what's the area of the entire hexagon? Well, if one of the triangles is 35, then the whole hexagon is going to be 6 times 35. So 35 times 6, it's going to give us 0, 3, 18, 210. So the area of the entire hexagon is 210. Hey, you know what's cool? You can totally use this strategy for all kinds of shapes. It doesn't just work for hexagons. So, for example, here we have an octagon. An octagon has 8 sides. It looks like a stop sign, right? So here's our octagon, and you can see just the same way, we could cut this up into 8 triangles. And then if we knew certain information about the lengths of the sides and the length of the height of one of those triangles, we would be able to solve for the entire area. Cool. See you in class.